First is internet video, and the system we study is called Twitch, which I believe many of you have experience watching video over with, and some of you might have experienced streaming video over Twitch. Well, those who don't have experience, it's okay. In the next 7 minutes, we take a video from one of the paper presentations we made, and that should give you a good idea what the Twitch project is about. Let me start by explaining why we study Twitch. It belongs to one of these major video services on the internet. The first kind, very well known, such as Netflix, YouTube, we watch playback videos. Second, we're using it more and more commonly today, such as Zoom, Google Meet, for the meetings, over distance. So these are called the conversational videos. What we're sending are actually live audio video and back and forth. So you can imagine the delay bandwidth requirement in the second category is higher than those in the first category. But the viewership, on the other hand, in conversational video, oftentimes we speak within a small group of people. So this is low. On the other hand, for playback videos, the viewership could be huge. Now, the third kind that is on the rise is called the live video broadcast, and Twitch belongs to this category. Now, YouTube Live is also more used these days, because of the content being live still, delay bandwidth high, and the viewership might be a surprise to many of you, is just as high as those in the playback video. And here's an example. Super Bowl, it's one of these major American football events on TV every year. It draws in millions of viewers. For example, in 2018, 98 million viewers tune in to watch, and it's well known the commercial time is the most expensive among all TV programs. But look at this guy here. LOL, it's one of these major online games. League of Legends, the World Championship Final. The scale of the game, the viewership is just as bad. I don't know if it's good or bad. 99.6 million viewers. And you know what? This event is broadcasted only on Twitch. So Twitch as a platform that hosts esports and gamer streams a lot. It actually draws in lots of viewers as well as traffic. We know already, this is not news, more than 80% of the internet traffic is video. And live video is growing really fast. In the pandemic, 2020, just between March and April, the growth rate is 45%. And Twitch is the one dominating live video traffic. In fact, the amount of traffic it's generating is just behind Netflix, Apple, Google, all these internet giants. Twitch's system is in fact straightforward. We have streamer on the left uploading video stream to the internet, and the viewers drawing the videos off of the internet. The subtle part is this. In order to allow upload downloads, we have these servers around. The videos are stored here and there. So we do have a CDN system behind, trying to satisfy the QoS requirement and satisfy the growing viewership. So you see the scale and accessibility of the CDN is a key design factor in a live streaming system as successful as Twitch. But you know what? Until today, little is known about Twitch's CDN. Now, our motivation is very straightforward. We just want to find out more. And the first bottleneck is to try to monitor Twitch's CDN continuously. You know what? We're not the first one curious about discovering these video services CDN and hopefully repeatedly. There's a string of work already, but many of these efforts are one-time only. Because what we do there is we repeatedly request these videos available on the platform. And by observing the IP addresses of the servers providing the videos, then we discover the video CDN. On the internet today, it's not exactly to do because of the probing overhead and because of where we can set up these probers. Second challenge, which might not be addressable really if you think about it, is it's always hard to argue how good the coverage is the CDN would discover, unless these companies would tell us exactly what the CDN deployment is. And what we're trying to say here is let's focus on the first challenge that is more addressable. And what we see towards long-term monitoring of a video services CDN is a two-phase scanner, two-phase prober. In phase one, instead of doing exhaustive probe through all videos, we only sample, and as a result, we only generate lightweight probing traffic. In the meantime, we're able to estimate the CDN size. Therefore, when we see the size change is significant, then we can go on and conduct the exhaustive full scan. Now here, CDN size is a very reasonable and intuitive indicator, okay, to trigger the full scan, because if there is a significant increase, indicating demand growth, indicating potential of a misconfiguration. A significant decrease, declining demand, or some sort of maintenance going on, or weird persistent outage going on. Now, in this paper, however, what we're talking about is how we address phase one. How do we do lightweight sampling and yet estimate the CDN size accurately? To that end, we borrow from ecology the capture, mark, recapture methodology. So ecologists have been using it to estimate the animal population in the wild. If you think about it, comparing animal population versus server population in a CDN, both are costly to survey, and we both, unless we're God, we don't know the ground truth. Okay, so our work is an attempt to try to apply ecological statistics to the problem of estimating server population in CDN. And you see now how we get the title of the paper, Twitch's CDN as an open population ecosystem. And that takes us to our problem statement. Our aim is to do lightweight sampling and yet being able to estimate Twitch's CDN size accurately. And this is necessary towards long-term monitoring in a cost-effective way. Coming up next is the two models we have tried and our effort collecting a data set so that we could understand the trade-off between the traffic overhead versus the CDN size estimation error. Sorry, we don't have time for the full story. In case you're curious, ask Polly for the full video. Now, with that background, you can imagine yourself working in one of these toy projects. First is, how about proposing a more advanced CMR methods? MLE, for example, is one of the methods used by the ecologist also. Okay, we have already started exploring this method, but it's not quite yet systematic or nor complete. And some other idea is potentially to divide the CDN servers based on their characteristics and estimate the size of each cluster independently and then combine. Okay. This can potentially reduce the computation complexity as opposed to doing MLE for the entire CDN. Okay. And for those who aren't familiar with MLE, in case the data is not long enough, it won't converge either. Okay. So this is an alternative approach. Last but not the least, it's not exactly easy to collect data. So it's very often that even though no matter how we try, the data is incomplete. Okay, so having loss in some of the hours we are taking traces or across days as well. So how does one compensate in the estimation method such that even though the data is incomplete, but we can still retain the estimation accuracy? The second toy project is full scan platform. So this is essentially doing the second phase of the long-term cost-effective Twitch monitoring project. So you can imagine that we are trying to build a cluster of computers that are crawling and discover Twitch's video servers. So what we're doing there is to program and design and find out the limitations such that we could do continuous crawl of Twitch's CDN that is temporally dense as well as geographically diverse. So in order to do temporally dense crawl in a reliable way, we need to know the system capacity so that we do not saturate, okay, the network, the internet, or generate complaints from Twitch. Okay. We want to be able to do geographically diverse crawl is because of this. If we crawl only from within NTU, from within Taiwan, we only discover CDN servers nearby Taiwan. Okay, so the characteristic of assigning servers when you access data on a CDN is this. The load balancer will often assign you a server that is close to you. So we need to be able to somehow connect to computers all around the world and do the crawling from there. Okay. This is called the big data collection, which is a topic that is one of the hardest in computer system research, computer network measurement research. Third is data analysis. I'm graying this part out because we'll be able to do this only after we have the data collected. And with the big data, we'll be able to mine the data and discover, for example, server allocation policy. So we'll be able to tell or backward engineer how Twitch assigned the edge video server to the viewer or the ingest video server to the streamer. And most of all, we as computer scientists will be able to observe the CDN of a major internet service and see how it grow, expand over a long time. Much like how ecologists observe a bird's habitat, how it expands in nature.